Okay, in this section 2-5, we're discussing multiplicity of zeros. And so the first concept here that we come to is, it says for a polynomial function, a factor of x minus a to the k power, okay, it yields a repeated zero of x equals a of multiplicity k. And so what that means is, okay, if it's raised to more than the first power, then it raises the multiplicity of the zero, right? And so here, if k is odd, right, the power is odd, then the graph crosses the x-axis at x equals a at the zero. It actually crosses if the power is odd. And if the power is even, then the graph, it just touches it, but it doesn't cross. So it goes back down the same direction. And we'll look at that on the graph here in just a minute. Okay, so this is just kind of another way of saying the same thing. All right, so that would be your zero, and then the power is the multiplicity. And this kind of says the same thing, that if it's odd, then it crosses over at that zero. And if it's an even multiplicity, then it just touches it and doesn't cross it, right? Okay, so let's take a look at one example here and kind of see what we're talking about. So it says, find the zeros of the function and state the multiplicity of each zero. And so in this case, since it's already factored out for us, we can just read off the zeros and look at the power in order to determine the multiplicity. So right here, you've got x equals -2 as one of the zeros, and that zero has a multiplicity of 2 because it's raised up to the second power, so you've got that same zero listed twice. And then we also have 4 as a zero here, and that's also raised up to the second power, so it has a multiplicity also of 2. All right, so we've stated the zero and the multiplicity of each zero. Now let's take a look at this example graphically so that we can kind of see what we're talking about here with the even and the odd power. Pull up our graphing calculator here, and let's plug it in. And so we'll have negative, whoops, I need my y equal first. Y equals negative, open a set of parentheses, and it'll be x plus 2 close squared, and then times x minus 4 close squared. Okay? And so you can see where the zeros are, and remember, in each case here, we've got an even multiplicity and an even multiplicity. And so remember what the chart said. If it has an even multiplicity, it just touches the x-axis but does not cross. And that's what we see here at both of our zeros, -2 and 4. Since the power is even, it just touches it, but it does not cross. If I were to go here to this squared, let's say, and I take the squared out and I put third power in there, look at the difference. Since it's an odd power, then it now crosses the x-axis at that particular zero. All right, and the same thing would happen if I went and changed the other one, say to a third power. Notice we still have the same zero, but the graph now crosses over the x-axis at that point instead of just touching it and going back down the same direction. Okay, and then it doesn't matter what I change this to. If I change this to fourth, we're back to even again, as you can see. If I change that to the fifth power, it's going to cross over it again, and sixth, and so on. All right, so that just kind of graphically verifies what we've been shown here in the notes. All right, a few more problems here to take a look at. Now, take a look at the way that this question is asked. It says to find the polynomial function with the given zeros, multiplicities, and degree. Okay, and so we need to find the function that has a 0 at -2 with a multiplicity of 3, a 0 at -1 with a multiplicity of 1, and that's a degree 4 polynomial. All right? So, how do we go about doing this? Well, remember, if we have the zeros and the multiplicity, we can write the function out in factored form. That's really all we need to write the function out in factored form. So it would be f of x equals, okay? For my first 0 at -2, that would be x plus 2. And remember, the multiplicity is 3, so I'll raise that up to the third power. And for the other 0, that would be x plus 1. And that's a multiplicity of 1, so I will just leave it at the first power. All right, so again, I've used the zeros and the multiplicities to write the function out in factored form. Now, here's what the issue is going to be. Okay, on a multiple choice, your answer choices are probably going to be in standard form. So in order to arrive at the correct answer, I'm going to have to go ahead and multiply this out. And so in order to do that, the first thing that I would do is go ahead and write this out multiple times. So x plus 2 to the third power is x plus 2 times x plus 2 times x plus 2. And then don't forget that you've got the x plus 1 on the back of that. Okay? So now I can start multiplying these things out with the distributive property. We can take a look probably at this one first. And so x times x is x squared. 2x, or 2 times x is 2x. Now when I slide over and then do x times 2, and I'll get another 2x. So really x times 2 is 2x, plus x times 2 is 2x. 2x plus 2x is 4x. We'll go ahead and multiply that out and add them together in one step. Then that'll leave me with 2 plus 2 to make 4. So that's multiplied out. Oops, wrote a 2, need a 4. Now I can multiply out that second set of parentheses together. X times x, x squared. 2x plus x in the middle makes 3x. And 2 times 1 makes 2. So now I got to multiply these two sets of parentheses together. And remember, it doesn't matter how many terms you've got in the parentheses, the rule is still the same. This one times everything on the other parentheses. This one times every number here, and this one times every number here, and then I just got to combine them all together when I'm done. So x squared times x squared, x to the 4th. Everything's plus here, so I don't really have to worry about signs. X squared times 3x would be 3x squared plus 2x squared plus, now I can slide over to the middle term, which is 4x to the 3rd. Oops. 4x to the 3rd. 4x times 3x is 12x squared. 4x times 2 is 8x. Now I can do the last term. 4 times x squared, 4x squared. 4 times 3x, 12x. And 4 times 2 plus 8. All right. Now I have some like terms I need to combine together here, and I'll have my answer. All right. So let's look at the largest term that we have here. And as a matter of fact, I may have wrote some of these in wrong. X squared and x squared is x to the 4th. I need to correct that, don't I? So that'd be 4th power. And this one would be 3rd power. I don't know if I said it correctly and wrote it wrong, or if I said it wrong and wrote it wrong. But in any case, I think we are correct all the rest of the way down now. Okay? So we're in good shape from here. And so now I've got x to the 4th. I don't have any other x to the 4th power. And so I'll just go ahead and write that one in and be done with that one. Now I've got 3rd power here. Now I've got 2 third powers, 3x to the 3rd and 4x to the 3rd. So that's going to be 7x to the 3rd. Let's take our squareds now. 2 and 12 and 4 would make 18 x squared. All right, so what about x's now? I see an 8x and I see a 12x to make 20x. And we got plus 8. All right, so this would be the answer that you would be looking for. Okay, so again, we have now written a polynomial function with zeros of -2, multiplicity 3, and -1, multiplicity 1. So again, we use that, write it out in factored form, multiply everything back out, and then you will have your correct answer there. All right? And as we can see, everything checks out. It is a degree 4 polynomial. Okay? All right, next one. Let's try it. So the first thing I need to do is I need to write out the function in factored form based on the zeros that they have given me. And so the first zero is 3, so that'll be x minus 3. Multiplicity is 2. We'll go ahead and square that. That'll be times. The other 0 is 2, so it'd be x minus 2, close, and multiplicity of 1. We'll leave it like that. Okay. So this one is degree 3, so it won't be quite as long to multiply out as the last one. So f of x, I do have negatives though to deal with. So let's write this out first. X minus 3 close times x minus 3 times x minus 2. All right, so we'll multiply these first two out first. X times x, x squared. And then that'll be minus 6x in the middle. And positive 9 there, negative times negative. Then I can take that now and multiply it times the next set of parentheses, which will give me x to the third minus 2x squared. Slide over to the negative 6, that's negative 6x squared. Negative and negative make positive 12x. Slide over with the 9 plus 9x and negative 18. So now I've multiplied all that out. Again, need to combine some like terms here and I'll have the answer. X to the third. My x squareds here, I can go ahead and put those together and make that negative 8. X squared. Can add the x's together and get 21x. And there's no regular numbers to combine with the 18. And so that is your correct answer. Okay? And we'll be back with the next lesson shortly.